degrees in radians?
Yes.
What?
It doesn't make sense. Do you have
Yes. Anybody else see the sheet from yesterday?
me?
Well, then you can't sit at my desk. Why? Because. Yeah, because Wyatt can't. Well, you're full of it.
I'm dead serious.
You look pretty today, though. That's a good color for you.
Still can't sit. Huh? Here. Yeah, but see, I didn't know it was a front page. I didn't know it wasn't projected. What the what?
What's the crap?
What'd you say?
Crap.
So repeat that?
He said crap.
So I actually, wait, are we supposed to Oh, yeah.
No, still same thing. So, like, if it's negative 75, where did my stuff go? Yeah. What's wrong with this board, bro? Yeah. Okay. Sorry. Your test.
They were already. Those were added?
I'm pretty sure they were. I'll go back and check. I'm very sure. Did you know what you made on the test? Yeah. Okay, it was added. Wasn't trying to make you say it in front of everybody. I just remembered with the 10 points you busted 100, so I didn't know.
I actually didn't do that. I did. Well, I did. No, like actually, like no offense, Charlie, no offense to I bet. I know, but like I don't pay attention.
I'm gonna look at them. I'm gonna look at them. All right, which one did y'all say? 27 and 18. I'm gonna do 18 since I'm already on that page, and then I'll come to 27. So 18 is 19 pi over 6. Yeah. So I'm going from, actually it says 2 coterminal angles, right? So I'm gonna add 2 pi. And then I'm gonna take the same thing and I'm gonna subtract 2 pi. Oops. Because that's how, if it's in radians to start with, which you know this is in radians, there's no degree symbol in the pi, give it away. You add or subtract 2 pi to find the coterminals. Yeah, because it said 1 positive, 1 negative. Oh, then you'd have to subtract it again. But just know, and you don't have to go back and do that, but just know that you can keep on it. So if you're on your calculator, do 19 divided by 6. 19 divided by 6. Oops. 19 divided by 6. And then add 2 pi or subtract 2. Not 2 pi, but just the 2. Put that, do math enter to put it back into a fraction, and then throw the pi up top. Since they both have a pi on them, it works that way. Does that make sense? Yeah. Yeah. So you could make this be 12 over 6. Yeah. What else on your homework? Which, by the way, this would be 31 pi over 6. You said 19? So 19 goes from degrees to DMS. So I'm going to start thinking, I know I have 36 whole degrees, right? Then I have 0.875 left. So what do I multiply that by? 60. 0.875 times 60 would give me 52.5, which means I have 52 minutes. And then I take the 0.5 and I multiply by 30 again, and I get, no, 6. Sorry. I'm jumping ahead. I'm sorry. And 30 seconds. Which other one did y'all say? 27? Okay. Oh, that's okay. All right, so then 27, negative 98 degrees, 12 minutes, 48. It's so quiet in here today. Is it Wyatt? Braylon? It's Wyatt. Ellen? Bless you. It's definitely not Ellen. How many? How many degrees, how many minutes are in a degree? 60. So I'm going to divide this by 60. How many seconds? 3,600. So I want to do boom, boom. I don't know what you get. 12 over 60 is 0.2. Three. No, I think that's probably right. Mm-hmm. I round it off, but yeah. No, that's fine. Right. Because I don't read those as, wait, let me think about this. That's where I just kicked Slade out. All right, look, I told you wrong on this and I apologize. No, it's not positive, but you subtract them all. The negative in front makes all of them negative. I thought that was my, yeah. Everything's negative, right. It makes everything negative. So it's not, it's 98.21333. So I apologize for that. Should have went with my gut. Right. They're all positive. That's correct. Yeah. All right. I know that y'all have a lot to do and I want to give you time to do your work. So let me show you what I got for you today. This is fairly easy. Arc length and sector area. I have a circle. Wait, who do y'all have here? Anybody else? Okay, Slade. Here's my theta. Okay. Arc length. Now, what is this piece called from the center to a point outside? The radius of the circle, right? So this is R. I'm going to tell you the trick to this is going to be that your theta must be in radians. If it's not, you have to convert it. Okay? It's the only way this works. Convert it over to radians. All right. Arc length. Arc length is the length, it's a piece of the circumference. It's this piece right here, right across from the theta. That is the arc length. Whoop. So if I want to know how far that is, there's a super duper duper easy little formula. Yeah. We usually call arc length S. I don't know why, but we do. You take the radius and you multiply it by theta. That will give you the arc length. But theta has to be in radians. If it's not, put it in radians. Theta, which is your degree. Right?
What is the theta? How do I put that in my calculator?
You don't, it's a variable. Just like x. Let me give you an example. Yeah, well, no, but we use theta represents an angle measure. Let me give you an example. You have a circle. We'll start with a radian one. Y'all got that? Whose angle in a standard position theta is 3 pi over 2. If the radius of the circle is 0.5, I don't know, feet, how long is the arc across from theta? Don't make this harder than what it is, okay?
What?
Yes. Okay, no. Look, it's r times theta, or theta times r. So the arc length is 1/2 times 3 pi over 2, which is 3 pi over 4 feet.
I was right.
That's all. It is that easy. Radius times angle. But your angle has to be in radians. So what happens if it's not? What happens if I'm given in degrees? That's exactly right. So for example, let's say my theta was 120 degrees and my radius was 1.8 feet. What is the arc length, the intercepted arc? What? Here? I don't know. Why? Huh?
He was just like, I wrote 13 kids up, and then I went to talk to him again. I look at him. I'm like, God.
What's 120 degrees in radians? Close. Okay, 2 pi over 3, that's my theta. So what is my intercepted arc length? Which means if I were to put 120 degrees on here, let's see, that's 180, so somewhere about right here. What is, if this is 120, what is this? I got 2 pi over 3 times 1.8 Or approximately 3.7699 feet. You did get that? That's it. Okay. We're doing one more. We're doing area too. Huh?
Oh, and then you divide it by the cube.
Y'all are making this ridiculous. Okay.
Butterfly.
Listen carefully.
Oh, carry the V.
Slade likes to ride the merry-go-round when he goes to the zoo. Are you asking a serious question? Oh. I did 2 over 3 times 1.8 on my calculator, and then I did math enter. Then divide by 3 and hit math enter. 2 divided by 3 and hit enter, and then times it by 1.8.
Okay. So enter. And then divide by 3. Like, you went, oh, what's that 3 from? I don't really have to be. I don't point
2 divided by 3. Leave the pi alone. We'll worry about it at the end. Yep, enter. Times 1.8. Enter. Math. Enter.
Why can't you do that though? Why can't you do like 1.2?
Okay, so because you need an exact answer and then there's an approximate answer. Be able to do both. Yeah. Okay, so Slade's riding the merry-go-round at the zoo. It rotates every time you pay to ride. It rotates a total of 2,808 degrees. How can it go more than 360 degrees if it's going in a circle? Multiple times, right? You'd be really mad if you paid your little $5 and you only went around one loop, right? So it loops around multiple times, 2,808 degrees per ride. If you sat 8 feet from the center, how far did you travel around the circle? How many feet did you ride around the circle? How many complete rotations did you make? I know I made 7 complete rotations, right? It's got to be in radians, remember? What did y'all get? How far did you travel? Anybody? What'd you get? That's what I got. We were but for this one, I wanted to know about how many feet you went around. It's okay. You can do fractions. What'd you get? 624 pi over 5 feet. Is that what you got? Yeah. So on your homework, it says, give your answer in terms of pi and rounded to the nearest tenth. So you'll give them both ways. Huh? Yes. All right, y'all ready for area? Y'all are making this a little harder than what it is. Take the same scenario with the same circle. Yeah. They go hand in hand. That was an easy one. It's literally r times theta. All right. Arc length deals with a piece of the circumference, right? The area deals with the area like a piece of pizza. It's this whole area here. Okay? A piece of pizza. The area here, 1/2 theta times radius squared. Again, this, radians only. Same other stuff, right? Yes, yes. It's got to be in radians. That little zero with the mark through is theta. That just tells me it's the measure of the angle. Okay. This is all over SAT and ACT if y'all haven't seen it before. I'm gonna do 2 problems, maybe 3. I'll do 2. I'll make this one. It doesn't necessarily have to be in standard position. On the x-axis is your initial side, and then somewhere around is your rotate. All right. This is 2 pi over 3. Find the area of the shaded region. Mark, set, go. Find the area of the shaded region. Yeah.
So that's already in radians.
It's already in radians, so I don't have to do anything with it. I don't know the answer yet. I haven't worked it.
No one going out there, sorry. Yeah, please don't.
Go back and be nice.
No, then you're over here teaching like you actually.
What?
Dude, hey. Oh.
No, that's not right.
Exactly.
Why is Sunny?
Don't look up if you're still working it. You literally are just plugging into that formula. I don't want to pause it. I want to finish teaching.
Absolutely, yeah. I actually subscribed. I want to.
You did get it right? Look back at your equation and we are just plugging in. That's all we're doing. I do want to do this one because this comes up again. In your car. Tell me when you're ready. Okay. You have to know how to do them. Yes. Oh my gosh. All right, you know how in your car, Charlie, shut your mouth. You know how in your car, when your windshield wiper goes, it's like your windshield wiper does this. Here's your windshield wiper to here, but you've got this little area like where it's just the arm of it. So whenever it cleans, you know what I'm talking about? Okay, I want you to picture this. It does. There's no blade there, right? It's just the arm. Okay. The windshield wiper arm is 32 inches long. Okay, so the whole arm, 32 inches long. So the whole entire arm is 32 inches. The wiper sweeps through an angle of 125. So we're not going to say 180. We're going to say it only goes a total of, because maybe it doesn't lay all the way down. Maybe it goes from like here to here. But anyway, it's going to go a total of 125 degrees. That's what it spans. Does everybody understand what I'm saying as far as what's what here? Okay. The length of the arm, so this length, the part that it's cleaning, is 21 inches. Y'all with me? Find the area that the blade cleans. So in other words, find that area. Talk me through it. What are we going to do? I know I got to convert degrees to radians first of all. I might as well go ahead and do that. 125 into radians. So times pi over 180. There's my theta. Area, I do 1/2 theta r squared, right? What am I going to do? What are you going to do? Talk me through it. What you got, Sonny? Whole thing. Everything shaded in pink is what I want to know the area of. But notice what's left out, right? I got to leave all this out. That's right. That's a separate problem. Okay, so so here's what we're doing. We do this in calculus all the time. We're taking the area of the whole thing, right? Which is going to be everything. So we're going to do the area of the whole minus the area of the whole, right? this part that's left out. So if we can find the area of the whole thing and then take out this little piece that's not included. So we always say area whole minus area whole, but you have to understand we're talking about whole and whole, right? W whole and little whole. Are you not entertained, Slade? You look like you're fixing to kill me with your death stare.
The whole.
Okay, so if you just do 21, remember it's measured from the center. So if you were to do 21, it would start here and measure to 21 here and give you the area, which is not going to be the same as if you take the big whole thing because the area differs so much because it's a circle as you go out. All right, so let's do the whole area first. The whole area would be the whole radius going all the way over, spanning 32 feet or 32 inches, right? So the area of the whole is going to be 1/2. Theta stays the same for all of it, yes? 25 pi over 36. Times radius squared. What's the radius of the whole entire thing? (1024). Divide that by 2. And then times 25 over 36. Is it 3,200 over 9? 3,200 pi over 9? Is that what y'all got? That's with it. I did everything together. Except for, I left the pi off, but multiplied everything together. No. I did 1/2 times 25 over 36 times 32 squared. Times 32 squared. Then math, enter. All right, now do the area of the itty bitty hole. What's my radius on that one? 11. How'd you get 11? Subtract it, right? The whole arm is 32. I just need that little piece of the arm that doesn't have a blade on it. So I need to do 32 minus 21, which is 11. So now I'm still the exact same theta, right? 11. Yeah. That's what I was saying. It's not accurate as far as 180 degrees. So maybe their wiper stops here and stops here. So that's really more like the area we're looking. But it spans 125 degrees as it wipes back and forth and back and forth. I got 3025 over 72 pi. So what do we say we need to do? Subtract them. This is in inches. So let's also get a decimal approximation for this. 985.02 inches squared. It's inches squared because it's area. Does that make sense? At all? A little bit? Caitlin says yeah.